Great, welcome back to grade 7 math. We are now on chapter 5.6, which is calculating the area of a complex shape. And a complex shape means a combination of two or more different shapes to make a new type of polygon. But you can break down that complex shape into the simpler polygons to find its area or to find its perimeter. So for example, if I have what looks like, let's say, a house looking polygon, some sort of pentagon, I can cut this up to make a rectangle and a triangle, calculate them separately. Equally, if I take something that looks like a hexagon, I can also take this and cut it into two trapezoids, and then I can calculate them separately and then add them together for the areas. For the perimeter, I'll have to look at which sides I have as well. So we've covered a lot of vocabulary this chapter, looking at polygons, quadrilaterals, triangles, parallelograms, trapezoids, rhombi, squares, and rectangles. So we'll just go over those definitions again. Let's start off with parallelograms. So if you recall, parallelograms are quadrilaterals or four-sided shapes that have two sets of parallel sides. So the way we draw parallels is with a little arrow like that, and we have two sets of them. So we have the top line, for example, is parallel to the bottom line, and the left line is parallel to the right line, which means those lines will never cross. And a parallelogram means that there's four-sided shape and two pairs of parallel sides. There's special types of parallelograms. The rectangle, what's so special about a rectangle is that it's a parallelogram with 90-degree angles in the corners. What's special about a rhombus is that it's a parallelogram with equal sides or equal lengths. Whereas a square is both a rectangle and a rhombus. So this has 90-degree angles and equal sides. This is just a review. We've done this before in an earlier chapter, but it is a lot of vocabulary, so we just wanted to review it. Triangles. There are different ways of categorizing triangles. We can categorize them by the length of their sides or by the measurement of their angles. So there's two broad categories of triangles. Let's look at sides first. An equilateral triangle is one where all of the sides are equal. That means the measurement of all three sides is exactly the same. In an isosceles triangle, that means two of the sides are the same and one side is of different length. In a scalene triangle, all three sides would be different. Now, what's special about an equilateral triangle is that because all of the sides are the same, all of the angles will also be the same. And so that means all the angles will be the same, means that all angles will always be 60 degrees in an equilateral triangle. In an isosceles triangle, because two of the sides are the same, that means two of the angles will be the same. These two here in the corner, depending on the size of one, the other one will be identical, and then the top or the apex angle will just be the difference between those two and 180. Scalene triangle, because all three sides are different, we can have a measurement of three different angles as long as it adds up to 180 degrees. So that's the categorization of triangle based on their sides. Based on angles, if I look at a right-angled triangle, it doesn't really matter what kind of triangle it could be. It could be isosceles or scalene. Can't be equilateral because a right-angled triangle has to have an angle of 90 degrees. Just one. Can't have two. An acute triangle has all three angles are less than 90 degrees. So all angles are less than 90 degrees. In an obtuse triangle, one of my angles will be greater than 90 degrees. So these are the two different ways of categorizing triangles, is either by their sides or by their angles. Trapezoids. So we saw a trapezoid. The definition of a trapezoid is a quadrilateral that has only one set of parallel sides. So in this case, the top and the bottom, or the big base and small base, are parallel. The other two sides are not parallel. There's a special type of trapezoid called the right trapezoid, and that means the height of the trapezoid is the same as one of the sides because one of the sides is at a 90-degree angle already. So that we call this a right trapezoid. An isosceles trapezoid is similar to an isosceles triangle, where we still have our parallel sides, but then the other two sides are identical in terms of their lengths. So those are just two special ways of of categorizing trapezoids. In terms of perimeter and area, the perimeter is very easy for all of these. You do not need to come up with any special formulas for the perimeter of any polygon. The perimeter of any polygon is the sum of all the sides, whether it's 4 sides or 3 sides or 6 sides, etc. We can also shorthand sum with the Greek letter sigma. The sum of all the sides is called the perimeter. Now we have to be careful if we have an example like this house example and we break it up into a rectangle and a triangle, that this inside edge or this inside side should not be counted in the perimeter. So this is not counted. Only anything that's on the outside of this polygon, so in this case this is a 5-sided polygon or a pentagon, will count in the perimeter. So if we have something that's on the inside, we should not count it in the perimeter because it's inside the object. Now let's just review the area formulas one more time. The area of a parallelogram is similar to the area of a rectangle or square or rhombus, which is base times height, where the height has to be 90-degree angled to the base. In any parallelogram, well, in a rectangle, for example, the height is 90 degrees already to the base, whereas in a regular parallelogram, I have to draw in the 90-degree height that's inside the parallelogram. In a triangle, if we remember, a triangle is just half of a parallelogram, so the area of a triangle is equal to base times height divided by 2. For area of a trapezoid, so if I draw this trapezoid here, and I have my big base and small base, what I need to do is I need to make a giant parallelogram. And so now I have to have an extra base and small base and big base. So the area of the trapezoid is equal to big base plus small base in brackets. These brackets are very important to show that you have to do that operation first before multiplying by the height. And then because it's only half of this big parallelogram, I divide by 2. So large base plus small base in brackets times height divided by 2. So when you take a complex shape, you can divide it into smaller shapes. You can add the areas together, but careful not to add the perimeters together because you'll just need to find the sum of the sides for that one. We'll do a couple of these practice questions in class. Then we're going to work on 5.7 next, and then we'll be ready